We have a graph that represents function f, which gives the height of the drone in meters, t seconds after it leaves the ground. You guys had to determine which function value is greater, and they're all in function notation, which we learned about yesterday. If you were not here yesterday, please make sure you're taking notes on your own time. If you ever want to help yourself to the note sheet back here, you can, but all the notes can be done on your own paper too. So no excuses. I even provide videos if you want the full experience, but the notes are in Schoology always. And really, each skill that we're learning, we're going to use in almost every lesson moving forward. So, describing graphs, function notation, we're going to use them in every lesson moving forward. So if you're not understanding, please ask sooner than later. But you'll use it for the rest of high school, and then if you go to college, also in college. All right, so we'll start with table 4 today. Is f of 0 or f of 4 greater? Okay, f of 4, let's see. So remember, for function notation, f of x equals y. So what's in the parentheses is usually your input, your x. So all these numbers are in parentheses. So that means when x is 0, what's my output?
Yep.
0, that I know for sure because it's at the origin. But when x is 4, my tick marks aren't labeled. But as we go up the y-axis, do the numbers get bigger or smaller? Bigger. So even though the axis isn't labeled, I know because this is higher on the y-axis, this one has to be greater, the f of 4. So good. Table 5 for the next one. Is f of 2 or f of 5 greater? All right, so let's see. F of 2, so when x is 2, we're going to see where that ends up on the y, so about here. And then when x is 5, go up, see what that y would probably be. Do you still think f of 2 is greater? They are actually what? Equal. They go up to the same level, like this is where it's not increasing or decreasing. So since they go up to the same value on the y, they must be equal to each other then. And what does that tell you about the drone in this part of the graph? It's the highest point. It is the highest point, good. What else does it tell you? If this is supposed to be my height of a drone and it's not increasing or decreasing, what is the drone probably doing? Staying still or just not going any higher or lower. It's probably just in the air doing its thing in that part of the graph at least. So good. Table 6. F of 3 or f of 7, which is greater? Okay, so let's see. Here's where x is 3, that's where the y would be. Here's where x is 7. So yes, definitely f of 3 is higher. So that's great. And table 7, which is greater, f of t or f of t plus 1? Okay, f of t plus 1. Raise your hand if you agree. Raise your hand if you disagree. Raise your hand if you have no clue. For the last one.
I have a question.
You have an answer, Benji?
Not that team.
Well, that's what table 7 said, and that's what I was seeing if everyone agrees, disagrees, or doesn't know. So let's see, let's test that theory. They didn't specify what time frame. So say I'm talking about f of 5 for the t, and then f of 5 plus 1, so I'm plugging in t for 5, which basically means f of 6. So let's compare like those 2 points. So here's f of 5, and here's f of 6. So in this case, the F of 5 is greater, right? So really the answer for number 4 is that it depends on what T is. Whether or not which one is greater. Okay, because if you try, say like 0 and 1, then yeah, this one will be greater. But, you know, it just depends on what T is. Because we have it going up, staying the same, and decreasing, it really just depends. So say we were talking about a linear function. What does a linear function do? Or what would it look like? A straight line. So it's either increasing the whole time or decreasing the whole time. Let's say that it's increasing the whole time. In that situation, yeah, f of t plus 1 would be greater, always, because it's always increasing more as we go further along on the x, right? But for this situation where it's going up, staying the same, going down, it just depends. Okay, so questions, comments, or concerns on the warm-up? All right, so we are on lesson 3 of unit 4. The goal today is to use function notation to talk about functions. So describing connections between a statement in function notation and the graph, using it efficiently because it is an efficient way to talk about things. Whatever two quantities we're talking about in a situation, and then use function notation to sketch a graph. So I record all my lessons, I'm recording right now. And the puzzle piece today is lesson 3. Again, like really you should have 1 and 2 done, but if you don't, make sure you do that. It's all in Schoology. I'm planned for literally the rest of the semester. All the unit 4 stuff is in there. So consider working ahead. The lessons are almost exactly the same as they were last year. Maybe just like a few activities are different. But it's literally all exactly the same. So we're gonna take a look. When you skip this out. But it's almost exactly the same. I think here's where we start getting to the drawing. So feel free to work ahead, but we're basically to the end. This is probably going to be the last reminder about the binder check for unit 3. So that's like your responsibility. If you didn't get full points on that, here's my last reminder to you. As long as I'm not in the middle of teaching, you could show me your binder. And I do not memorize what pages that you were missing. You would have to show me all the pages again. But it was only 7. They're all in Schoology. You could get that knocked out in 20 minutes. And then that goes in the projects category. That's the only thing that goes in the projects category. So 20% of your grade is just you taking notes. There's no reason that should be anything below 100% in that category. Questions on what I said so far? So like some of you could be passing if you just turned in your binder checks, but there's only so much I can do. Here's all the assessments for the rest of the school year. You might have a quiz over the second part of unit 4. But other than that, like this is it. I don't anticipate these dates changing. And really, there's only so many Wednesdays left for tutoring, including today, and Saturday academies. So if I was trying to keep a certain grade, whether it's an A, B, C, or D, if I was trying to maintain a certain grade, I would be going to all the tutoring that is being offered to be getting my grade up. So for example, we still have a unit to get through. Say you've been at a 70% all semester. If you decide, oh, I'm okay, I'm good, and just bomb it completely, now you're at a D. And it's really the end of the semester. There's only 1 tutoring after that day. So that would be like your last chance to get any sort of help in that part of your grade. So everything that we've been doing so far, assessments, projects, and homework, that's all 90% of your grade. This last 10% comes from your finals. So it's still possible, like you could essentially lose a letter grade, which I feel like not care about the finals. I know it's 10% doesn't seem like a lot, especially when we talk about homework. But when there's only two things going in a 10% category, it could affect you. That's why I'm saying if you have like a grade that's near where the next letter grade would be, don't assume that the final is gonna bring your grade up. Just assume that it's not. So that way you're doing everything you can to make your grade more solid. So it's like, I was that kid wanting to keep my C. Instead of just going to the final with the 70%, I would be working to get it to like at least a 76 or an 80 or something like that. If I was wanting to keep a C. Because in order to keep the grade you currently have, we have to score at least that much on the final. So say you have a B, you want to keep a B. If I have an 80%, I have to score at least an 80% on the final. And in my experience, most kids don't score 80%. But we'll talk about more how the finals are set up, but I'm just trying to tell you, if you want a certain grade, you need to be working now to do that, to get that grade. So questions on anything I said? Okay, so then now on to the next activity. So let's talk about smartphones for a second. We have function P gives the number of people in millions who own a smartphone T years after the year 2000. You and your groups need to figure out what each equation here tells us about the smartphone ownership. So I should expect like a sentence from each of you. And then down here, you're going to use function notation to represent each statement. So then I should expect something that looks like this for your answers on number 2. All right, since it's 4 things, I'll give you 4 minutes, but you probably don't need 4 minutes. And we'll go through the tables after that. So table 8, what does P of 17 equaling 2,320 represent?
I think it's 2,030, like 2,320 people had smartphones in 2017. Okay.
So let me rephrase that. In 2017, how many people had smartphones?
2,320.
Okay, anyone disagree with that? Okay, now think about 2017 was not that long ago, it was like 6 years ago. Do you think only 2,320 people had phones back then? So reread the first sentence that was given to you. How can we revise this to be more clear?
Millions. So the like 2 billion.
Good. So you could make this say million right next to it. Or if you want like the number, it is in the 2 billion.
That makes sense.
But it's 2,320 million, which is about 2.32 billion. Make sense? That makes a bit more sense than only 2,000 people having smartphones. Make sense? Yes. Okay. So then table 9, what about P of -10 equaling 0? What does that mean?
In 1990, nobody had phones.
Okay, good. So in 1990, nobody had smartphones at least. Questions on that? Because obviously we can't have a negative year, right? But they specified that T is years after the year 2000. So if it's negative, that must be before 2000, which would be 1990, if it's -10. Questions on that? All right, so then table 1, now you're doing the reverse. You're giving me the function notation for the statement, and it's in 2010, the number of people who owned a smartphone was that number. How can we make it kind of look like what was given to us in the first two? Right, so class, agree, disagree? So the 10 should definitely be in the parentheses. That's the time since 2010, which is 10 years. The 296.6, well, let's see. It had to be in millions. And what is this figure in? Well, here's like my 100,000 part. This part is in millions. But if I put this big number here, like the whole thing as the output, then that would suggest like an additional 6 zeros, if that makes sense. So I have to basically condense it to be 296.6 million, because it's still in the millions part. So this is correct. You should have a decimal. But if I times that by something, I don't know, 100,000 or million, it'll give me that figure. So questions on that? All right, so next one, table 2. In 2015, about 1.86 billion people owned a smartphone. How do I write that in function notation? Okay. 1.86. All right, class, agree, disagree? Does the input look good? Does the output look good? Okay, some are saying yes, some are saying no. Reread this and then reread the first sentence that was given to you. What is your output supposed to be in? So millions, and it gave it to you in billions. So if I put this, that implies 1.86 million when it's actually billion. Okay, so what that should actually be, what's the difference between a million and a billion? How many zeros?
3. So
what you should actually do is times this number by 1,000, because 1,000 has 3 zeros. And that will give you the figure in millions versus billion. Okay, so when you do that, I believe it is 100 or 1,860. Please tell me if I'm wrong. So 1,860 million, which is equivalent to 1.86 billion. Or just let me check if I have it. So questions on that activity? Can we go to and forth from function notation to what it represents? Okay, so then let me just verify that I put the right number there. Okay, yeah, I did. All right. So I'm gonna switch it now to 3 and 4. If you're writing, hurry up or get it from someone at your table. But that is correct for part B. So then now we're gonna do 3 and 4, which is still about that same situation. So we have May is curious about the value of T and P of T equals 1,000. What would the value of T tell May about the situation? And it's for a possible value of T. Once you've done that, you are going to sketch a graph of all the information that you do have. So let's go back to the information that we do have for a second. We know that f of x equals y for function notation. So really, each of these can be written as a coordinate. What's the order that coordinates go in? X, Y. So because each of these have an X and a Y, each of these that you do know can be written as a coordinate. So like for number 4, one of the points you need to graph is this. How would I write this one as a coordinate? What's my X in this situation? -10. And what's my Y? 0. So that's another coordinate, and then you can make coordinates out of these two as well and add it to your graph. All right, so I'll leave this on the screen right now for a second. Our f of x equals y. I'll leave this on the screen for like 30 seconds, but you're doing 3 and 4 on your paper. Questions? Okay. Table. So everyone else needs to wrap up their conversations. We're done with that. Table 4. What would the value of t tell May about the situation in p of t equals 1,000? Okay, so the year since 2000, that what happened? How can you incorporate that 1,000 in your answer? And how many people would this be in millions? Or I guess many figures? What's 1,000 million equal to? So it would be the year that 1 billion people had smartphones. Or you could have said 1,000 million, but really it's 1 billion. That's what that value of T would tell us. In what year that 1 billion people had smartphones. So then table 5, based on what we do know, which is really only those 4 coordinates from the first part of the activity, based on what we do know is for a possible value for T. Okay, and why do we think not? Okay, so let's look at what we do know. So yeah, the 4 for T would mean 2004. So if we look at what we already figured out. All right, in 2017, we had about 2 billion already. In 1990 we had 0, so that doesn't really help us. In 2010, we had not 1 billion yet. All right, so if in 2010 we didn't reach 1 billion, do you think it would make sense that we actually reached it in 2004? Because we weren't even there at 2010. Do you think as the years progress that more or less people get smartphones? So I agree with that. I do not think T would be a value that doesn't really seem reasonable. If in 2010, we're not even close to 1 billion yet. We're still like 700 million away. Okay, so yeah, good answer. Now for the graph, our graphs could look a little bit different from each other, but you definitely need to have these coordinates. And then if you wrote these ones in coordinate form, you would have that as well. So 17, 23, 20. So if you haven't done that, do that now. I did that. I didn't mean for a comma to be there. I'm just writing down what we do have from the previous activity. Okay, so these are the 4 things that we figured out from the first activity. It said from the information provided, that was all the information provided. So on our graph, we should definitely have points at these locations. So like 17 would be here on the X. 2320 looks like it would be about here. Because it looks like on the Y, there each tick mark is 200. So 2320 would be between 2200 and 2400. And we'll graph the rest. So then also know the coordinates go X, Y. So -10, 0 would be here. 15 up 1860. Right here. And 10 up 296.6. Right. You do definitely have points in these locations. And again, do we think that as the years progress, so as we go to the right of the graph, should there be more or less people owning a phone? More, that would make more logical sense from what we know. So then you would connect, oh, let me ask you one more question. Do you think our graph should be a continuous line? Or just dots like a scatter plot? So here's how you can figure that out. So listen, important, run. Important. So can you have like a fraction of a year? A decimal of a year? Yeah, there's months, weeks, days, hours, seconds, all of that within a year. So yes, that supports we should have a continuous line there. And then for the Y, can I have a decimal of a million? Also, yes. So that supports why we should have a continuous line versus a bunch of random dots. Because you can have fractions of both. Right? So your graph might look something similar to this. And you definitely need points where I'm putting my dots. Questions, comments, concerns? All right, almost done. So we have one more activity on the back. Now a new situation. We have to relate it to whatever situation going on. This one on the back is about boiling water, so I'm going to switch the page now. Also, maybe for this graph, include this vocabulary word. This is a continuous graph. So when it's a line versus like a bunch of dots, we call that continuous. Not a scatter plot. It's continuous. All right, but anyway, I'll start reading this. This is what you and your group will do. You'll take turns verbalizing each answer, and I'm going to be listening for it. Also, you could jot it down so you don't forget. But we have the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove, T minutes after it's turned on. In your groups, so whoever's sitting closest to where I'm at right now, you'll start, and then you'll go to the left. But so each of you should talk. Some of you should be talking more than once. But you're going to take turns explaining the meaning of each statement based on the situation. And if you disagree with whoever's talking, make sure you guys work that out so that you come to an agreement by the end. And then we'll go over them in a few minutes. All right, so you're going to take turns saying what each statement means, agreeing or disagreeing. And then you'll sketch it based on what you do know on that little graph there. All right, since there's what, 5 things? 5 things. I'll give you 10 minutes. No, not 10 minutes.
Yes.
That's a really long time. I'll give you 10 minutes only because when you're done, I'll let you start to practice, but you need to have answers to this first. We'll go over it in exactly 10 minutes.
Yes.
Have answers to this and have your draft sketch.
Yeah.
I should hear each of you talking, some of you talking twice. Andre? 0 equaling 72, what does that mean in this situation? There's all have something written, just someone read it to me. Okay, so the stove was on for 0 minutes. And the water was what? Oh. 72 degrees. Okay, good. And we're talking about degrees Fahrenheit. I mean, would you necessarily phrase it like that? Maybe there's some variations. But at 0 minutes, or basically at the start of them boiling the water, it was 72 degrees Fahrenheit, the water. Questions on that?
No.
Okay. So then, table 8, for W of 5 greater than W of 2, what does that mean?
The pot of water has been boiling for 5 minutes. All right, no.
Okay, everyone else is having a conversation and not listening.
Oh, the water after 5 minutes is probably the water.
Okay, good. So the temperature of the water was higher at 5 minutes than 3 or than 2 minutes. Was higher at 5 minutes than at 2 minutes. All right, that is correct. We don't know what the temperatures were, but we know that after 5 minutes, it was hotter than at 2 minutes. So then table 9, what about W of 10 equaling 212?
When the stove was on for 10 minutes, it was 212.
So at 10 minutes, the water was 212 degrees Fahrenheit. Which, if I remember science correctly, I'm pretty sure that's the boiling point of water, but we'll see. The water was 212 degrees Fahrenheit. That we know for sure. Table 1, W of 15 greater than W of 30, what does that mean? So what was higher? Okay, good. So the temperature of the water was higher at 15 minutes than 30 minutes. Sorry, it takes a while to write it down. Hopefully you already have it written down. The temperature of water was higher at 15 minutes compared to the 30 minutes. All right, last one, table 2, W of 0 less than W of 30. What does that mean? So the temperature is higher at 30 minutes than at the start, yes. Okay, perfect. Now, you had to take that information and graph it. So let me see if I can snip the graph on there so that I don't have to change it for people that are still writing. But there's only a few things that we know 5 things for sure. But there's only 2 parts that need to be the same on all of our graphs. So let me snip the graph for a second. I will go back to it. Hang on. Okay, so there's only a few things that we know for sure. So what coordinate do I need to for sure have on my graph? Full class. Like what we did earlier. Okay, good. This can be a coordinate because that's an equal sign. Here's my X, here's my Y written as a coordinate. I should for sure have that point on my graph, which would be somewhere here. And since it's X is 0, that's my Y intercept. Good so far? What other point do I need to for sure have on my graph? For C, because that's also an equal sign. What's the coordinate? Okay, perfect. So you also need a dot where 10 and 212 is. The rest, we just have to know, like, we don't know where exactly it should be, so we can have it in different places. But we just have to know, like, when X is 5, that should be higher than where X is 2. So like probably increasing from here to here. Right? Here is higher than where X is 2. Over here, we know that at 15 minutes, that's greater than at 30 minutes. So we just need this to be higher than the 30. Just kind of estimate it. We don't know how much it went up, but we know at the end it got a little cooler. So something like that. And then double check for the last one. Where it started, when X is 0, still needs to be less than when X is 30. And it is in the way that I put it. So it should have something similar to that. So that can be exact. All right, questions on today? You still have some time. I wouldn't have it yet. The practices are normally really short. You can knock out a few questions here. So you should have your lesson 3 done today. Okay. Go ahead.